Good day, ma'am. Sorry. Good day, ma'am. My name is Teniola, and today I'm going to be building a monomer of one of the carbohydrates. So the monomer I chose to build is glucose. Now, glucose has the same formula. The same. Now there are two other monomers of carbohydrates, which are fructose and galactose. Now, glucose has is a structural isomer of both of those monomers. Why? Well, because glucose has the same formula as fructose and galactose, which is 6,6H12O6. But it has a different structure than both. So I'm going to show you the structure of glucose. Then after that, I'm going to show you what polymer can be formed from glucose and how it can be formed. So sorry. Okay. So as you can see here, you have a drawing with pencil here. So the line represents the bonds. So this is a bond, 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 this is a bond. And glucose has a ring-like structure. So it has a ring-like structure. It has a ring-like structure. So I'm going to put the corresponding carbon, hydrogen, and oxygen where they belong in this structure here. Also there's also sorry also there's supposed to be five carbons in each of these five spaces. So one, two, three, four, five, and there's going to be one oxygen atom in this space here. So let's start. So as I said, you have five carbons. So first carbon, second carbon, um so that's a space. I mean, like there'll be five carbons bonded to each other like this in the interior of the ring like structure. There'll also be one oxygen atom bonded to two carbon atoms. I don't mean spaces, I made a mistake. So there's going to be another carbon here. Sorry. Yeah, there's going to be one carbon here, one carbon here. Sorry. And there's going to be an oxygen atom with my sharpener. So also my hydrogen atoms are erasers. So my carbon atoms are toothpicks and my oxygen atom is a sharpener. Now, I've done this. Now I can see here an oxygen atom is bonded to two carbon atoms because the drawn lines with pencil represent my bonds, and there's five carbon atoms bonded to each other. Now, where the six carbon atoms supposed to go? So it will bond with the carbon on top. So it will bond with this carbon here. Now, each of the carbons are supposed to have four bonds between each other. Now, we already know that sorry. Now, because of now each of the carbon atoms are supposed to have four bonds. So we already know that this carbon sorry this oxygen atom is actually bonded to this carbon atom only. I made a mistake as well. So each carbon atom is supposed to have each carbon atom in the interior of the in the interior of the ring like structure is supposed to have four bonds. So to make that four bonds happen, we already have this carbon atom to have two bonds, which is carbon bonded to this carbon atom and carbon bonded to this carbon atom. So to make that happen, we need to add more atoms. So we'll add a hydroxyl group, which will be hydrogen and oxygen bonded together, which will make another bond. So this carbon now have three bonds, which are one, two, and three. And we'll now add two more hydrogen atoms. I'm so sorry. You now add two more hydrogen atoms. Yeah. So we now add two more hydrogen atoms here. So that makes my four bonds. So this will apply to all the carbons. So we'll have a hydrogen atom here, oxygen here, sorry, hydroxyl group there, something like this. So something like this you have it as well. You have it in the other in the right side as well. You have a hydrogen here, you have an oxygen atom here. Then you also have a now for these two, the last two here, it will be quite different. So you have a hydroxyl group bonded to the carbon atom here, and you now have one hydrogen atom down below. So it'll be something like this. So for this one here, you have a hydroxyl group bonded on top, and you have a hydrogen atom bonded down. But for this one here, you have a hydroxyl group bonded down. So sorry, I'm not showing this very well. But you have a hydroxyl group bonded down. I have one hydrogen atom bonded on top. So this is this is glucose basically, a household materials. Now in our thing, so how will you make polymers? So basically, every polymer is so a polymer is basically a polysaccharide. That's in terms of the scientific, so polymers of carbohydrates are basically polysaccharide. Now to make a polysaccharide, you need to bond this glucose with other glucose molecules, and the linkage between this glucose molecule will be called a glycosidic linkage. And one of the examples of the polysaccharide you can make is starch. So starch can be made by bonding many monosaccharides, which will be glucose molecules basically. Thank you, Ma, for listening to me. Hope you have a nice day. Bye.